Okay, so we start. Any questions from previous lecture or quizzes? Okay, so if not, the turn on video. Yeah, okay, so today we will do the chapter 2, and today's topic is coding, the more like the computer coding. So how to deal with the repeat. So we use the while loop and the repeat loop and also for loop. And also that we study how to make a if statement. For example, if n is an odd number, that we add n to 1 or something like that. So the if statement. And also that we study how to write a function. So last time in exercise, last week, we make a values of some function, but sometimes it's convenient to specifically develop a function that will do some of your projects. So more the core coding is today's topic. And after that, we do some exercises, hopefully. So to be specific, we study chapter 2 from the slide, I think 24 to slide 42. Okay, so I will share the screen. Oh, I got some question, maybe. Sorry, hitting. Oh, that's fine. Okay. Yeah, so turn on video and we can start the lecture. And yeah. Yeah, so we study the while loop and the repeat loop, and also we study for loop. For loop is after this for loop. So the difference between while, repeat, and for is that the while and repeat are used for loop with unknown number of iterations. And the for loop is a loop for a fixed number of iterations. So for example, if you know how many times you have to repeat, for example, you have to repeat 100 times, then we should use for loop. And if we don't know how many times we have to repeat some procedure, then we use while loop or repeat loop. Repeat and while are very similar. They're almost the same functionality. And one example is here. So suppose that we want to find the smallest n such that the 2 to the nth power is larger than some specific number n. N is a given positive integer. So suppose that capital N is this one, so 123,456,789. And for example, 2 to the 10th power is 1024. So it's certainly the smaller than capital N, but this lower case n gets larger and larger. At some point, 2 to the nth power exceeds this capital N, and we want to find that n. We want to get the smallest the possible n, such that 2 to the power n is larger than capital N. So in this case, okay, so we try at first 2, next 4, next 8, and next 16, and 32, and so on, until that number exceeds this capital N. So we don't know how many times we have to repeat. So in this case, we should use the while or repeat loop to get the answer. And this lowercase n is the length of the integer n when the binary system is used. For example, the 6 in the decimal system is 110 in the binary system. In the binary system, this 0 means just 0. This 1 means the 2 times 1, and this 1 means 2 squared times 1. So the 6 is 110, 4 plus 2 plus 0. So 2 to the second power plus 2 to the first power plus the 2 to the 0th power. So the so 0 times 2 to the 0th power. So that is 110. So 6 has binary length of 3, but this is actually the this length 3 is obtained by the fact that the 2 to third power is larger than 6. So 8 is larger than 6. Okay. Yeah, so this has specific meaning, and we want to develop a procedure to automatically calculate this. And here is the way to code this. So this is capital N. So we defined this at first. Then we set the initial value for N. Maybe you start with 0 or you start with 1. And the while 2 to the nth power is less than or equal to capital N, we add 1 to n. So we start with 1, but the 2 to the first power is less than capital N, so we make n equals to 2 next time. Then we check if 2 to the second power is smaller than or equal to n, and certainly it's not, so we add 1 once more. So n is 2, then 2 plus 1 is 3. So we replace, and we replace 2 by 3. So the n to 3, and so on. So by the way, if you cut and paste this code, it does not work in R. So this is strange, but the hat symbol, we have at least on Mac that we have 2 different font for this hat, and this small hat does not work. So you can see this is our screen, and suppose n is I don't know why we have Greek letter. Suppose n is 1, and this actually does not work. We have to use the larger hat. I don't know, we have 2 symbols, and anyway, and yeah. And actually, if we run this procedure, the R immediately returns n is equal to 27. So R try n is equal to 1 first, then n is equal to 2, 3, 4, 5, and finally 2 to the 27th power exceeds this capital N, so it returns 27. Actually, if we calculate 2 to the power 27, then we get the 134 million, the 17,728. So this is slightly larger than this capital N. So the format should be like this. While the parenthesis, then condition, then after that, what you want to do. Do you have any questions? Yeah. So R repeats this 26 times. The first n is 1, last one n is 26. N is 26, we add this one again, then n is 27, then this condition is not satisfied, so it stops without doing this. Another way to, yeah.
I'm sorry to interrupt
we got
you.
some question in chat. Maybe how do you write multiple expressions like the parentheses in one line? I'm not sure how do you write multiple expressions like that in the parentheses?
It's referring to the second part in the braces. I think it's referring to how you
I
do
see that you
multiple.
want to do multiple things, maybe. I think that should be fine as long as you didn't close the brace. So yeah, for example, okay, so we make equivalent code, which is the less efficient, like the while 2 to the power n. Okay, so maybe n is equal to 1. And while the 2 to the power n is less than or equal to n, maybe at first that we define the new n as n plus 0.5. Okay, then next, yeah, actually you can return this and you can write next one, like n is n plus 0.5. This is equivalent code, right? So then, sorry, I didn't define capital N. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Then, and n is n plus 0.5, like this. Then you get n is equal to 27. So just you can use multiple lines. As long as you did not close brace, that you can do multiple things within this parenthesis, this brace. And if still you are, yeah, so that's it. Yeah. Or if you want to write it in the same line, you can use the semicolon. Then this is another equivalent code. I think that we have to write. So I think that we have to use the, okay, so we go back to n is equal to 1. Then if you write this code, separated by semicolon, this is the same as this code. So this should return n is 27. Yeah. Yeah. Okay, so any other questions? Okay, and the this next one is the same code, but by using repeat function. So capital N is the same, small n is the same. Then we write the repeat n is defined by n plus 1. And if 2 to the power n exceeds capital N, then we stop. So break stops the procedure. And otherwise, we continue. So then, you know, the first time 2 to the nth power exceeds capital N, it breaks so that we get the n is equal to 27. But this code is slightly different in the sense that we haven't tried to compare 2 to the first power is larger than capital N, right? Because the lowercase n is 1, but we at first add 1 to n. So we didn't check 2 to the first power is larger than n, but actually it starts with n is equal to 2, right? And then if this condition is satisfied, then we break. So yeah, so finally we do the same thing, but it starts with basically we start with realistically n is equal to 2, right? So it's slightly different from this one. So sometimes while loop is more convenient to use. Sometimes repeat is more convenient to use, but basically it did the same thing. Any question about repeat? I think that you can just stick with while maybe. Sometimes maybe repeat is much more convenient, but I haven't had such experience many times. Actually, in statistics, we don't have any many cases that we use while loop. You know, optimization, or if you go into algorithm, that you need it. But otherwise, you know, as long as you are using some packages, probably you are not really using this many times. Okay, so if you don't have maybe another message is repeat the same as while true. So almost the same. That's slightly different, right? So the actually the while function, you just put the opposite proposition to the while function. While function that we put to this condition, and repeat function we use the just the opposite of this, the original proposition. So the slightly different way to use, but basically the same objective, the same objective. So next one, the if statements. And the first, I have to discuss one new symbol, this double percentage sign. So this is the basically the remainder. So if you divide 100 by 3, the remainder is 1, and the returns remainder. So 100 divided the remainder when 100 is divided by 3. Okay, so this is the one example of if statement. Actually, if statement is in the previous page as well, but this is a simpler example. So when an integer n is given, the print congratulations on screen if and only if n is divisible by 9. Then n is 17, and we put n double percentage 9, the double equal 0. So this is the condition that the n double equal 9 is equal to 0. Then print congratulations. So actually, this n 17 is not divisible by 9. So it does not show anything. But if n is 18, if you type this line, the R returns the congratulations. Actually, this function is also a new function, the print function, just to print something on screen. Yeah, so this is very practical, the situation. For example, you do some iteration in R. Maybe you are doing some simulation, and the simulation is very long, and you have to iterate some procedure maybe 1,000 times. But you want to see if the R has successful progress. So every, the 9 iterations that you want to see congratulations. So then you have to, include this line in the middle of your code. Then you can see the progress. So this is often useful code. If I run simulation with 300 iterations and it will take 300 minutes, then I don't want to wait for 300 minutes. So maybe every 10 minutes, I want to see if the progress, do the job, does the job correctly. So we want to see the intermediate results. So we use this kind of thing. So this is how to use if statement. So if parenthesis condition, then brace and print something. Actually, this brace is not necessary if your job is very simple like this, but if it includes multiple lines, then you certainly need this brace. Any questions? Yeah, this is if statement. And this is another way to use if statement. So if x is, okay, so suppose we define x as 0.3, and if x is less than 0, that we define y as 0. Otherwise, else the y is defined by 1. So in such a case, we use this if-else statement. So if condition, then this, maybe you can put this in a brace as well. Then else, then maybe brace, y is equal to 1. Then x is actually not satisfying this condition, so y becomes 1. But if x is negative 0.5, this condition is satisfied, so y is defined as 0. So y is 0. So this is if-else statement. So if condition is satisfied, we do some job. Not satisfied, then we do another job. Any questions? Okay, and next one is not new, but the is more complicated example. So yeah. So this is okay. So we support that we define x is 12, and this if statement has this condition. So actually, I combined two conditions. This means x is between -10 and 10. So x is larger than -10, and x is less than or equal to 10. So that means x is between -10 and 10. If this condition is satisfied, we define y as 1 and z as 2. And if this condition is not satisfied, actually the x is -12, so this condition is not satisfied, then we define y as 0, and we define z as -2. Then after this code, after running this code, it returns, R returns y is 0 and z is -2. So to get two results at the same time, I use the vector notation, the vector of y and z. So y is 0, z is -2. And this plus symbol is nothing. So just if you type the multiple lines in R, automatically it shows the purple plus. That's the you shouldn't type this one. So if you input this, you should erase these pluses. But this brace should looks a little strange. But this just declares. Yeah, so this is a little strange. That's true, but basically this declares that the if statement didn't end at this point. So yeah, maybe I cut and paste and I run this code. Sorry, I didn't define x. So x is -12. And we do this, and c y0, yz is 0, 2. So this works well. But actually, if we don't put brace, probably it does not work. This sometimes confuses me as well. Yeah, we have something wrong. So basically, this means the R interprets that this if statement is just independent. So we close the brace. So the R just thought that this is one self-contained statement. So R just run this. Then R suddenly see another else. So it returns error. So to avoid this, that we have to put the brace sign here. I cannot really explain well why R works this way, but if we want to put else in the next line of this, the closing the brace, we have to put in this way. Probably it's much easier to write. This way. Sorry. Sorry, I got something wrong. If we put this brace else brace in one line, there is no room to make R confused. So anyway, so this line continues. If this statement is true, then R does this code, and otherwise else, then R do this code. So probably this brace sign is confusing. So probably it's much better to code like this. So the important thing is this brace, the else brace, this is included in one line. Yeah, so it's important to not to make R confused about your code. So it should be clear that where the line ends. For example, if you want to calculate 1 plus 2 plus 3, that is 6, that's fine. And 1 plus 2 plus, change line, then 3, it returns the same answer. But 1 plus 2 return plus 3, then answer is different. Right? So because the R thinks that this statement has already been completed. So you shouldn't write in this way. So that's the point. Any questions? Yeah, so my daughter, I don't know if she's good at mathematics or not, but even on paper, when she write equation, always she write like this: 1 plus 2 plus, then change line and 3. Otherwise, the expression is not uniquely defined. Okay. Any questions? So this is a very practical example, using the AND condition. Also, remember that OR condition can be stated by vertical bar. Is this class will be using loops to assign values to arrays? Yeah, sure. Yeah, especially matrix. Yes. Maybe 3-dimensional arrays are rare, but yes. I will have only example for us manipulating vectors, but yes, yeah, I will discuss it today later. Okay, and next one is the function. The f of x is equal to x squared. If we want to define function, then you can use function. Statement function. So if we want to define the square function as x squared, the square, then we define this as function of x, function parenthesis x, then brace x squared. This brace is not necessary if you only have just one line of code, but my recommendation is to put this always. If you have multiple lines within brace, the brace is really necessary. So square of 9 is 81. So once you define this, then square function can be used at any time. And actually, often the function works for vector. For example, if you put 1, 2, 3, it returns 149. As long as this statement doesn't have any problem to be applied for vectors or matrices, then you can directly use this, like the square of vector or square of even matrix. Matrix 1, 2, 4, 2, 2. A is this, and the square A. So R is not really strict about the class of the input. As long as it does not make an error, it's fine. You may define this as x as a scalar, but also it may work for vector, matrices, possibly some other classes. Function can take any input. For example, you can define a function to input and output are anything. So for example, you can define function g as, okay, and the function g is actually actually the input of function is a function. That is also possible. And that is maybe f of 3. Such function can be defined. So for example, in this case, okay, so we have function square, right? So if you put g square, then it returns 9. Because if you enter 3, the square of 3, it becomes 9. So such a function is possible. Such a function is possible. Also, maybe g is a function of f, and it returns the value of the function from 1 to 5. In this case, if we type square, actually the output is a vector with 5 elements. So this function in R can take any input. Actually, it can take multiple inputs as well, but yeah, we will have some examples later. Any questions so far? Okay, so next, a little more complicated function. So last time, in the beginning of the class, I calculated the lowercase n such that the 2 to the nth power is larger than capital N. So we want to find the smallest n such that the 2 to the nth power is larger than capital N. And we want to do this for many different numbers. So last time, the 123 million was used as capital N, but we want to write a function to do that job for any capital N. So then we can define a function on capital N. So we name this as binary length function. Then we can put the code here. At first, we define n is equal to 1. And if the 2 to the nth power is less than capital N, then we go to the next n. Then finally, we return n. This is the return value. So these 2 lines of code is actual code, and this is return value. So finally, we return n. If you define this function, then if you type binary length of 1, 2, 3, 4, 5, 6, 7, 8, 9, then it returns 27. Any questions? Okay. And we want to generalize this function a little more. So last time, I take the 2 to the nth power, but generally, we want to take the q to the nth power. Maybe we think about the 3 to the nth power or 4 to the nth power and so on. We want to generalize this. So in this case, we have 2 inputs. One is q and one is capital N. And the answer is that we want to find the n, lowercase n. So this is a function of q and n, capital N. So we have 2 inputs, q and capital N. And we do the same thing, n as 1. Then when q to the nth power is less than capital N, then we go to the next n. Then finally, we want to get the 2 values as return values. So one is n, and also we want to see the q to the power n. Then if you type this, it returns this. So this means that 3 to the 17th power is 129 million, 140,163. So if you put the 2 and this value, then it should return 27 and the 132 million or something from the previous page. Yeah. Yeah, so it can take 2 values. Any questions so far? Why is Q defined? Oh, that's a good question. The Q is the input of this function. So actually the Q is defined when you use this. Yeah, you input this. Yeah, so Q and N, the user using this function that should specify it. So you should not, you don't, actually you should not specify in this function. Right? And N is, lowercase n is defined here, so that's fine. But if you are using some other numbers like a and b within this function, that should be defined before this function. That's true. So Q is specified here. That is the answer. Okay. Any other questions? And my recommendation to study this course material is just to stick with the slides first. The slides should be self-contained. So if you understand the slides 100%, then you should be able to solve all quizzes and assignments. Sometimes maybe you want to have more examples, then you can see the R book. R book is the pretty comprehensive reference. Also, you can refer a textbook, but I think that my slides have more information than the textbook. So our book is a good reference if you want to have more examples. Okay, so next one. Okay, so the same function as the last one, the q-adic length. Sorry, this is the name of the previous function, right? Q-adic, yeah, q-adic length function. And actually, we can set the default value for q and n. So yeah, so suppose that almost always we use q is equal to 2. And almost always we use the capital N here. Then these are default values for q and capital N. So in such a case, even if you don't specify q and capital N, then you get the answer. So these numbers are used. And if you want to change some value, for example, if you keep capital N, but you want to use different q, then you can write the q-adic length, q is equal to 3. Then it returns this. And yeah, sometimes you can set just one default value. Maybe you can set default value for n, but not for q. So in such a case, you always have to define q. So in such a case, even you don't really need q is equal to. So q-adic length 3, then it returns these numbers. So the point is we have multiple inputs, but also you can set the default values for the inputs. Any questions? Yeah, so this is what we have already discussed. That's you can set any objects as the input of the function and the output of the function. So maybe typical example is the input is data frame. That is one thing. And the output, yeah, output is usually some object, but also you can output some files to the external folder. For example, you can save a file. You can make a function to create figures and make a JPEG file or something like that. Yeah, so these are the ways to do the if statement and while and repeat statements. Probably this is the most complicated in terms of coding in R. Later chapters that we study more about statistics. So yeah. And I think the last one for real coding is this for loop. So for loop is used when an operation needs to be repeated for a fixed number of times, 100 times or 10,000 times. So it can be used for simulation, for example, or it can be used to fill out some matrix. We have 10 by 10 matrix, then we want to fill out each number, each cell by some number, then you can use for loop for I is equal to 1 to 10, I may be a row number, and the j is equal to 1 to 10, that is the column number. Yeah. So this is different from the repeat and while, because repeat and while loops are used when the number of iterations is unknown in advance. Yeah, and this is the simple example of for loop. So X is a 5-dimensional vector. Okay, so you can see X is just the vector of 5 elements, 0, 0, 0, 0, 0. Then we want to put 1 in the first element, and so 1 square in the first element, and 2 square in the second element, and 3 square in the third element, and so on. Then you can use this for loop in this way. So the format is for parentheses, and this is any parameter. I used I, but it can be J, or maybe you can name it something. So you can use the cars as a parameter or something like that. So the I is in 1 to 5. This is 1 to 5. My recommendation is almost all the time that you keep this as a sequence of 1 to something, 1 to 10 or 1 to 100. But you can specify different sequence, such as 0 to 4, or maybe 6 to 10, or even just you can specify the vector of 3, 5, 7, 9, 11, or something like that. So this is, in general, any vector, and you can do it. And it does not even have to be numeric vector. You can do this for I is equal to the 3 names, maybe the Andrew and the Bob and the Catherine or something like that. So any vector. Then the X bracket I's element of X is I square. Then we close. Then after that, the X, if you type X, it returns this. Any questions so far? Okay, so this is how to use for loop. I think the for loop is probably easier to understand than repeat for a while. So just we do the same thing the multiple times. Yeah, one slightly more complicated example. So suppose we want to create a vector of the first differences from this V. So original vector is x1, x2, x3 up to x sub n, but we want to take the difference from the previous observation. So x2 minus x1, x3 minus x2, and so on. How to get the plus to, I got a question. How to get the plus to appear at the beginning of each line? Actually, that automatically appears. So that is just this display. So for example, the for I is equal to 1, maybe we define x. Oh yeah, for I is equal to 1 to 6, 1 to 5. And if you return, then automatically the plus sign appears here. Then xi is equal to maybe I square minus 1. Yeah, that's it. Okay, so go back to this. So if we want to create this vector from this V, you can use for loop. Certainly, you have to repeat some procedure n-1 times. So it starts with x2 minus x1, and it ends with xn minus xn-1. So we have n-1 elements. So certainly, we know the number of operations. Of course, the n should be known, but the v is a vector. So say we have 100 elements, so 100 is known. So we have to repeat 99 times here. So we know the number of repeats. So you can do this way. So the input is a vector v. So at first, we calculate the length of v, and the resulting vector should be shorter by 1 element. So we define the w by vector with n-1 element, n-1 elements. So then you can do this way. For loop, I is equal to 1 to n-1. Then ith element of wi is equal to the v of I plus 1 minus v of 1. So actually, this first element of w is x2 minus x1. and so on. Second element is x3 minus x2. Then this is a function, so we have to have output. So this is the return value, w, so output. Then this automatically makes the w from v. So if you have vector x, and if you input x in this function dv, the resulting vector is 2, 3, 4, 5, because 3 minus 1 is 2, 6 minus 3 is 3, 10 minus 6 is 4, and 15 minus 10 is 5. Yeah, so often to use for loop, the good strategy is to make some object first. Then we fill out this object, the elements of the object. And actually that is much faster, for example, compared to every time makes this vector 1 longer. So when you declare something or you modify the structure of something, the language takes time. So good strategy is that you define some object and just keep the shape of this object, and you just manipulate numbers. Okay, so this is another way to code the same thing. So just that we want to make w vector from v, but actually we can avoid for loop to define a function, and here is the way. And okay, so input is v, and we check the length of v first. Then we define w as this. So this is the vector form. Okay, so second element to nth element. Then this is first element to n minus first element. So in this way, you can generate v2 minus v1, v3 minus v2, v4 minus v3 at the same time with this only one line. And we return w. Then if input is x, then this function returns these values. So the output is the same. And actually, this is much faster than the previous one. So if you have only 1,000 observations, almost the same. But if you have 1 million observations, this code is faster than the previous one. Why? Because R specializes in fast calculation for vectors and matrices. So vector calculation is faster than for loop. So in maybe more low-level languages such as C language, the for loop and this kind of code almost have the same speed. But for matrix languages such as R, Python, MATLAB, so this vectorized code is much faster. So just avoid for loop. Actually, this is simpler code, and also it's faster. So as long as it's possible, it's better to avoid for loop, especially if you have many for loop nested. For I is equal to 1 to 10, j is equal to 1 to 100, k is equal to 1 to 10, and we have to run many times. For example, the so I is equal to 1 to 10, and the j is equal to 1 to 100, and the k is equal to 1 to 50. Then in total, you have to run this for loop 50,000 times, 10 times 100 times 50. So in such a case, as long as possible, it's better to avoid for loop. Yeah, so this is more like the application, and the function can be used to create complicated plot. So last time that we draw the line graph of Michigan and Wisconsin's temperature, and it's pretty complicated code. So just we want to automate that procedure. So x1 is x coordinates for the first data, y1 is the y coordinates of the first data, and x2 and y2 in the same way for the second data set. And we want to get the figure of the two line graphs overlaid as the g1.jpg. Then we can write this kind of function. So the function of x1, y1, x2, y2, and possibly some other graphic parameters to control the color of parameter or something. And we put it as just a variable. Then we define the range for x and the range for y within this function, JPEG out2 function. And we declare JPEG file with name g1.jpg, and we create the plot of the first data set, and we overlay with the plot of the second data set. And then so we output this the JPEG file. So JPEG and the dev.off parentheses is the one set of code. And then if you have these data, these variables, then JPEG out of this automatically outputs g1.jpg file into your working directory. So this file has been automatically generated. Any questions? If not, maybe we can do exercise 3 this time. Exercise 3 is available on the website. So I will set up several breakout rooms. So we do exercise 3. But just before that, I will see exercise 3. Exercise 3 is available on the website and here. So basically, you have to define some functions. So calculate we want to define, if the vector is given, we want to calculate this. So this is called the mean absolute deviation. So at first we calculate mean, x bar is the mean, sample mean, and take xi minus x bar, then take the absolute value, take summation, and multiply it by 1 over sample size. And something like that. If you have time, go to question 2 and 3. Okay, so we divide this class into how many students? 1, 2, 3, 4, 5, 20 students here. So maybe 4 or 5, maybe 5 breakout rooms. And for 35, maybe 13, 14 minutes. Yeah. Okay, enjoy your conversation. Alex.
question, Professor? Oh, you're muted, by the way, if you're speaking. Oh, unless I'm muted. Professor? You're muted, I think. All right, maybe I'm muted. Never mind.
Yeah, go ahead.
So how I solved this problem, we did not have to use a loop, right? Like we didn't have to.
Actually, you don't really have to go use loop. Yeah, actually, one way is to use loop, but actually not necessary to use loop.
Okay.
Okay, so maybe yeah, I will explain that the first question at least. Yeah, so we want to calculate the mean absolute deviation of these numbers. Okay, so maybe just for convenience, we define this vector as x 3.1 and 2.8 and 4.0 and 3.5 and 3.3. So first, it's good to see how to calculate it manually. So basically, okay, so we need the mean of x, and we have to subtract x, the mean of x from x. So this returns these 5 numbers, right? So just 3.1 minus this mean and 2.8 minus this mean. This is vector minus scalar, but that is actually interpreted as each element of x minus this scalar. So these are 5 numbers. Then after that, we take the absolute value. The easiest way is to take absolute value of this, ABS. If you don't know absolute value symbol, maybe you can take maybe, x minus mean of x, just then, the maximum of this and the minus of this. This is also possible to do it. Sorry, the maximum, oh, maybe. Yeah, that is complicated. Maybe apply of, yeah, something. So sorry, but just ABS function we can use. So ABS function. Then we take summation. So we take the summation of this. Then that is 0.24, plus 0.54, plus 0.66, and so on. So that becomes 1.64. Then we divide this by 5. So that is what we want, finally. So the question is, the answer is 0.328. And the developer function to calculate the mean absolute deviation of a vector. So maybe we define the MAD function. So mean absolute deviation function, mean absolute deviation function. Actually, MAD function already in the package I heard. So yeah, that's maybe, sorry, but maybe we define the mean AD function. Mean AD function is function of a vector X, maybe just in general vector V. And what we want to do, at first we take the average of V and we take the difference, then take absolute value of each element, then take summation, then divide by the length. So maybe 1 over length of V. So in this way, mean AD function of V, mean function of X becomes 0.328. Yeah. Of course, you can make a for loop for these 5 observations, but as long as it's possible, it's good to avoid for loop. And the trick is here, the vector minus the elements is calculated by just this argument without using for loop. Okay, and generate the 100,000 independent standard normal random numbers by the following code, then calculate the mean absolute deviation. So set seed. To get the same answer on every computer, we set the seed for random number generator. Then define R norm of 100,000. Then and the mean AD of Y, there you get this number. I think the sum of the rooms got this number correctly. So basically, we calculate the mean absolute value of this. So this is the histogram of Y. So, these are random numbers. So the distance from center to each value maybe ranges from 0 to maybe 4.5. And on average, the distance is 0.798. So standard deviation is 1, but this is absolute the deviation. So it's different from 1 and actually about 0.798. And question 2 and 3, I think the one room was doing question 2 at least, but I think we don't really have time, so I will upload code, solutions for exercise 2 and 3 sometime soon. Do you have any questions? Okay, if not, so I will assign quizzes later and see you next week.